Hello, this is Mr. Jarrett, and in this video tutorial, we are going to be 3D modeling this bolt in SolidWorks. So you notice here that the origin is located right in the center of the cylindrical head, okay, and it is a flat head up at the top, and you can actually see that because it says flat here. So the origin is located right on the end of it. This bolt is laying down and going backwards, and you see we actually have threads on here. So I am going to teach you the difference between using the actual thread tool and doing what's called cosmetic threads. This picture only shows cosmetic threads, but I'm going to show you how to actually cut real threads in that using the thread tool. So this is in inches. That's our units. So we're going to make sure that we're set in IPS before we get started. Okay, so if you haven't already, you can pull this to your other screen. And in SolidWorks, let's create a new part. And we need to make sure that we are in IPS. My computer defaults to IPS, so if yours is not, please set yours to that. And we are going to sketch right on the top plane. Okay. Now, if you notice how that rotated us flat here, in order to have this thing laying down and facing the direction that it is, meaning getting our center of mass, what's specified, we're actually going to be drawing this bolt kind of standing on its head, going up. And I'm also only going to draw half of this profile because we're going to use the revolve feature. Okay, so from here, let's get our line tool. I'll select the origin, and I'm going to draw right up the middle. Okay, I'll draw that flat bottom. It is chamfered, so we can actually just draw this degrees in. You could use a chamfer tool too. Doesn't really matter, but then I'm going to come down here. It goes out. That's the base of the head, that little lip, and then it curves. So I'll hit escape and I'll get my 3-point arc tool. I'm just going to click there, click somewhere up here, project it across from the origin. Just kind of make it like that. And I'll get my line tool and I'll go back to the origin. Okay, so that's the bolt kind of upside down. So now we can start to dimension this, but make sure before you do that that anything that's supposed to be horizontal or vertical is horizontal or vertical. Okay, so if you don't have these relations, please set those. Let's get our Smart Dimension tool. And looking at this picture, we can kind of start to pull off bits and pieces. Okay, so it says right here that this flat part, okay, this little thin flat part, has a height of 0.031 and has a diameter of 0.422. Now, since we are only drawing half of this, we will have to divide this number in two so we get the radius, but the height, however, that does not change. Okay, so let's do that first. So the height of this, so if we just click on that little straight line, that is going to be 0.031. Okay. And now from this line to our center line, the one going up the middle, that is going to be half of 0.422. So you could either just do that math in your head, or you can make SolidWorks do it. 0.422 divided by 2. Okay. Let's pull this measurement back up, and I'll set that to 3 decimal places just so you can see it. Notice I did that over here by clicking on the unit precision. It just determines how many decimal places there are. So if you really want to actually do that for all of these, you can. You don't have to because the number is still there. You can see that actual measurement, but that just helps you visualize and make sure you have the right stuff in. Okay, so we have those two things. Now, if I pull this back over again, working on the head still here, it says from that flat part to where the origin is 1/8 of an inch, 0.125. Okay, it says the flat part itself has a diameter of 1/4 of an inch. So again, if we're only working on half of this, that means it's going to be 1/8 of an inch. So we're going to be putting in that number, 0.125, 2 times here. So from that flat line down to this flat line, or down to the origin, that is going to be 0.125. Again, if you want to change that to 3 decimal places to display that, you can. Okay, it says the measurement for this needs to be half 1/4 of an inch. So again, we're going to be making this 0.125. Okay, so those lines are now fully defined. Again, if you want to change this, you can over here. But we see our arc is not fully defined. Okay, now if we look back at this, you see it says SR. SR means spherical radius. So the difference between radius and spherical radius means that when you're kind of drawing this, you need to keep in mind that it was once a sphere or a big circle in this case. Okay, so that means we may not have our tangencies there. So I'm going to pull this back and kind of explain this again. If I set this to tangent, and this is not going to be correct, so you understand that. If I set this to tangent, okay, when this fully extends, if you click on this, you see the center point is right here, okay? That means this being a complete sphere would not actually be equal to the other one on the other side as well, okay? Because my center point's here. So in order for the center point to be located in the center, so if this were to continue, it was one big sphere or one big circle, we cannot have this tangency here. So I'm going to kind of delete that tangency. And when I set this measurement, you'll see what I mean. So this measurement is going to be 0.236, just like it says. You see how it puts the center point here. So this is no longer tangent. Okay, it's no longer tangent, but it puts the center point here. So just to kind of show you that, and I don't want you to draw this, but when we revolve this entire thing, you see how when this is a big sphere, over here on the right side of this, this would also be one round piece, meaning it all actually connects to this, okay? So SR means that you're not going to have the tangency that you normally would have if you were going to revolve. Okay, so this is now fully defined down here. If you do want to change that measurement to be a unit precision of 3 decimal places, you can. And now we just have to worry about the threaded shaft of this. So first off, let's actually deal with the chamfer, because I know when you start to put in other measurements, it may screw up your chamfer. So that says on the picture that it's 45 degrees at 0.03. So I'm simply going to click this bottom line and my angle line, and out here on the angle, I'm going to make that 45 degrees, okay? And the height of it, so if I click on this line again and move out, my SolidWorks is glitching, the height of it is going to be 0.03. So 0.03, okay? 0.03. So we have the degrees and we have the height of it, or the height length, I guess you could call it. All right, now looking at this a little bit further, going through this entire thing, we cannot use this measurement yet down here because we're not to that point. We have this done, we have this done, this done, and that done. So the only thing that we have left is this threaded measurement here. So learning how to read the threads is a key part of knowing how to do this. But this says it is 1/4 - 20 UNC times 1. Okay, so if you don't know how to read a thread count, this can be confusing. So the 1/4 is actually referring to what's called the largest diameter or major diameter. So that would be from the outside of the threads to the outside of the threads. Okay, the 20 is actually how many threads there are per inch. UNC means unified course, so it means they're going to be filed off edges, not direct points. And the 1 means the total length of the threads. Okay, so it is 1 inch here. So the main number that we're going to be focusing on just for this is not necessarily the 20, but the 1/4 at first, and then the second thing would be the 1. Okay, so the 1/4 is the diameter. Now, again, since we are only drawing half of this, we need to be cutting that in half. Okay, so I'm going to get my Smart Dimension tool, and I'm going to select this interior line and the central line, and that's going to be half of 1/4, so 0.125. So that is going to be an eighth, okay, 0.125. Now this is still blue because it doesn't know that total length. So The common misconception here would be to click on this line and make it 1 inch. But keep in mind, this portion where my mouse is actually inside of the head. So when they do threads, they actually are only counting the thread portion of it. So that's actually from this line to the end is going to be 1. So now that I'm fully defined and I have all my measurements in, I'm going to go over to the Features tab and hit Revolve Boss Base. And here it's just asking us for the axis of revolution and how far around do we want to revolve. Well, we do want to go 360 to make it a solid shape. And the axis of revolution is going to be this interior line, so that middle line. When we hit the green check, we now have a solid bolt. Okay, so the two things that we still need to do is cut this at the end, and we need to actually cut the threads in. Okay, so I'm going to hit Control-7 since I rotated it around here a little bit. And now I want to sketch on this flat face. So I got my sketch tool, I clicked on that flat face. I'm going to hit Control-8 so it rotates nicely. And if you notice here that it has a hexagon. Okay, so I'm going to use the polygon tool, and a hexagon has 6 sides, so that's what's already defaulted to it. It doesn't matter if you're inscribed or circumscribed here, but I'll click right on my origin, and I'm just going to draw out to the side. Okay, I'll hit Escape, and since this can still rotate, in order to get the center of mass perfect, I'm going to click on this dot, hold in Shift, and click on the origin, and I'll set those to being horizontal. So it can no longer rotate. Okay, it can only get bigger or smaller. Now what it does say here is that it is going to be 5 30-seconds across the flats. So that means when we dimension, so get your smart dimension tool, we're going to select one flat side to the opposite flat side, and we're simply going to type in 5 divided by 32. I don't know that number off the top of my head. Probably should, but I don't. Okay, so that, as you can see, is 0.15625. Okay, so if you want to set your measurements here, you can. I believe that's going to be 5 decimal places. You can set that if you really want to. But now that that's in, it's fully defined, we'll go to the Features tab and Extrude Cut. And it says that it is 0.111 deep. 0.111 deep. So it's going to be cut into the head like that. Okay, green check. So now we have the head portion all done, completed. Now we need to do the threads. Okay, so for the threads, I'm just going to rotate around a little bit so it's a better view so I can kind of see underneath. So like I said, in that picture for this activity, it shows what's called cosmetic threads, meaning cosmetic is like a fake. It's just a picture. It's almost like makeup on there. Okay, and that's what cosmetics is. So here's an example of what that would actually look like in SolidWorks. I do have one drawn that is cosmetic threads, as you can see over here. See how it's just a picture? So it's still the cylindrical object and it's just a picture. Yeah, that looks fine. That's all well and good, but it doesn't give you the true mass of what this object would actually be if you actually had those threads cut into it. Because SolidWorks is just calculating this being a solid cylinder right now. Okay, so what we are going to do is actually use the thread tool. So the thread tool is located underneath the whole wizard. So get your thread tool. And if it gives you a warning, just press OK. Okay, and the first thing it says is the thread location, So we are going to actually click on this little rim right here. Okay, so click on that inside ring. And then rotating down, it says end condition. So you can select up to selection. Okay, and we'll click on that. And we want the very end of this, very end of this. So you see that it's going to continue to cut those threads even past that end. Now we selected that end and we did it in this fashion because realistically, you would be filing this chamfer so that it screws on easier. So that means your threads would be actually cut off. Okay. On the other end, however, it will stop clear of what that actually looks like. Okay, so that's all good as far as the selections. Now the size, I don't know if my SolidWorks just defaulted to this because it's the last time I used it, but what we need here is following what the picture says. It says it's 1/4 in major diameter and it's 20 UNC, okay? So you can hit for size, and you might have to go down through here, but you want 0.25-20. Okay, 0.25-20. These are just defaults for that size. Okay, we actually want the cut threads because it's going to cut it in. If it was a hole, okay, if this was a hole, we'd want the extrude thread, so it would pop them out. But here we're actually cutting it in. As far as the option goes, it does not determine in the picture if it's right hand or left hand thread. If you want to get real specific, a right hand or left hand thread would be determined by an underscore here. I probably already taught you that before. The right hand or left hand thread. Okay, so if it actually has this underscore, then it is a left hand thread. But since ours doesn't have anything, it's not really determined. We have to assume it's the right hand thread. Okay, so we have the right hand thread count selected, and you can simply hit the green check. Now this is pretty cool. It automatically cuts this little triangular shape away, and it revolves it all the way around the central axis of this. So that is pretty amazing that SOLIDWORKS can do something like that just by a couple simple clicks. But there is the shape of our bolt. So let's now change the material. And it says the material for this is going to be cast alloy steel. So you can right click on the material and set it to cast alloy steel. Let's check our mass. Okay, our mass here is going to be 0.01 pounds. The volume is 0.05. Surface area is 1.53. And our center of mass, as you can see, is 0 for the X, 0 for the Y, because it's symmetrical. And it is a negative 0.5 for the Z. So if you got that, you can save this and move on to the next one. If you didn't, please problem solve and figure out where you went wrong.